Today we're going to talk about empowering a data fabric architecture with StreamSets. To start, I'd like to talk about StreamSets' point of view on a data fabric. It has two components. The first is a data mesh powered by smart data pipelines. The data mesh exposes data as a service to business users. This is an existing functionality within StreamSets today, and we'll see a demonstration of that shortly. And as part of Software AG, StreamSets will be integrating with the Web Methods framework to build out even further functionality as it relates to a data mesh. The second component is a metadata layer, and this is going to include things like platform metrics, data schemas, and transformation logic. But importantly, in StreamSets' point of view, this should be done automatically and should be inferred from the data. And this is what's built into the StreamSets platform today. StreamSets can infer and automatically calculate metadata and write that metadata to Calibra or Apache Atlas. However, going forward, we're going to be building a first-class application to provide a knowledge graph and an advanced search for data consumers. And later on, we're going to see a mock-up of what that might look like. Now, let's take a look at a demonstration of how to build a data mesh architecture within StreamSets. We're going to use the data collector to create a web service backed by MySQL that can create, read, update, and delete records based on an HTTP request. I'm going to demonstrate calling the service from the command line, but you can just as easily imagine using a tool like Postman or a front-end user interface to query the data. I'm also going to demonstrate how you can transform data in the pipeline, which will alter the data before the response is sent back to the user. In this example, it will ensure that callers of our API won't see a social security number returned back from the database. So the first thing we're going to do is head over to our terminal, and we are going to look at our table. And we have a table called user data. So if we describe this table, and if we look at this, we can see that there is currently no data in the table. Now let's go back to our data pipeline in StreamSets. So our origin of this pipeline is a REST service origin. We have a request router that is going to route various requests to various downstream processors. So the post is going to get routed to a JDBC processor that creates records in a database. The GET request is going to get routed to a JDBC processor that looks up records to return to the caller. In the middle here we have this field masker, and this is going to ensure that any caller of this API is going to have their social security number masked before it's sent to the destination. And lastly, we have a response destination that's going to send the response back to the origin. And when we do this, we're going to return a 200, and we're going to add a special header, which is the title of the pipeline, to the request. Let's go ahead and start this pipeline. So the pipeline is going to be running. So let's go ahead and run a post request to put some data in our database. So if we run HTTP post, I'm going to create a new user called Tim, and I'm going to put their social security number in, and the ID is going to automatically be added. So when I run this, I get a 200 ID, which is 1, my name, Tim, and then my social security number, which is masked. If I go over to my database and I select the users, I can see that the social security number was successfully added in the destination. Now, suppose that we want to update Tim's name in this table. So to do that, we can do HTTP patch, and what we're going to do here is we're going to say for ID equals 1, update the name to Timothy. So if I run this, I get a 200 on my request, and if I come over to select from my users, I see that my name was updated to be Timothy. Now let's come back and talk about how StreamSets is going to be building a metadata layer within the DataOps platform to empower the data fabric architecture. For starters, we'll be adding a knowledge graph. The knowledge graph built at the topology level and driven by a user-specified context from a filter. The knowledge graph will automatically detect, dynamically calculate transformation logic and schema information and display it to the user within their context. From within the knowledge graph, the user will be able to drill down into individual transformations and see the transformation logic within individual components of the overall data flow topology. Then the user will be able to dig into the transformation logic itself and see the schema that was dynamically inferred as data was flowing through the data pipeline. And lastly, the user will be able to search all of that information dynamically and see information that's relevant to the context in which they provide the platform. And that is how the platform will empower a data fabric architecture.